So before we begin 11.6, we're going to review 11.5. 11.5 went over prisms and cylinders, but a cylinder had the same volume formula of a prism, and that was the area of the base, and then times the height of the whole object. So to find the volume, you're going to first need to know what the base is, what shape is the base. Remember, in a prism, there are going to be two parallel and congruent bases. They're going to be opposite of each other. So this one, again, is a funky looking shape. A lot of people see the rectangles first. These are not parallel, so these are not the bases. This front one does not have a back square that is opposite and parallel to it, so you would want to look at the top. This is a trapezoid. Trapezoid has one pair of parallel sides, so this one and this one. Same thing on the bottom. So, we're going to find the area of the base, which is a trapezoid. The area formula for a trapezoid was 1/2 base 1 plus base 2 times the height. So remember that these two bases are going to be parallel to each other on the trapezoid itself. And then this height is the height of the trapezoid only. So we are looking two-dimensionally. We are looking solely at this trapezoid, and you're kind of ignoring everything else in the picture. So, to start, our two bases are going to be parallel to each other. It's what makes the trapezoid a trapezoid. So it's going to be that 7 and then this 4. So 7 and 4. And then the height of the trapezoid is what separates or pushes apart the bases, or the distance between the two bases, if you will. So the distance between the two bases, you see this dotted line, it is the height, which is 3. You'll want to do PEMDAS, which means 7 plus 4, which is 11. It does not matter what order you multiply in. I'm going to do 11 times 3, which is 33. And then half of 33 is 16 and a half. So that is the area of the base. We found that. Now we need the height of the entire object. So the height of the whole object is what pushes the bases apart. It's also what makes this three-dimensional, right? So, what pushes my two bases apart, I'm going to highlight in orange. That's the distance between the two bases. So the length is going to be 13, the length of the height. So multiply by 13, and we get 214.5, and then it's meters cubed, because remember, we're answering a 3D question, so you need cubed units. This next one, find the volume of the composite solid. So composite, if you think, like in real life, you have composite wood, a composite bat for baseball. It just means that there are two shapes put together. So we're going to find the volume of two separate figures, and then we're either going to add them or subtract them. So let's look at our picture to figure that out. We have a rectangular prism up here, right? And it has been added onto another rectangular prism. So since they're added together, you're going to add them together. What I mean by that, let's say you had a box. Pretend that this was pretty. It's not. It is what it is. And then like the box had a cutout or something. Like a cutout in the side. So pretend like this is hollow. You would subtract it. It's not a beautiful picture. It is what it is. But you can very clearly see this is like two boxes stacked on top of each other. So the volume that can fit inside of this whole object and this object, you're going to add together to figure that out. So we're going to find the volume of the top. So again, that formula, area of the base times the height of the object. So this is a rectangular prism. You can pick the top and the bottom to be your base. You could pick the sides to be your base. It doesn't matter as long as they are opposite. So I can't highlight everything, but so looking at the top rectangle, it is 4 centimeters because the area of a rectangle is length times width. We're finding the area of the base. So 4 is the length, and then the width, you don't see a number here, but what I do know is that down here is 2 centimeters, and these two lines are congruent to each other because the two bases are congruent. So 4 times 2, which is 8, area of the base, times the height of the object. The height is what pushes apart your two bases, so that would be 1 centimeter. It pushes apart the two bases. So times 1, obviously 8 times 1 is 8. So I'm just going to highlight this. This is not our final answer. I just want to be able to find it later. We're going to find the volume of the bottom object. I'm going to copy and paste. Boom. Oop, boom. So we're going to only be looking at the bottom figure. We're going to forget about the top figure for now. But we only want to focus on the bottom box. So again, area of the base, you're going to find the base. We could call the bottom the base again. It's a rectangular prism. So any two opposite sides can be a base. So length times width. So 9 by 7. 9 times 7 is 63. And then the height of the entire object is what pushes the two bases apart. So that would be a 5. So times 5. So we get 315. So what we're going to do is we're going to add these two numbers together. The volume of the top was 8 and the volume of the bottom was 315. This adds together to 323, and then it'll be centimeters cubed. The last problem that we will review is this triangular prism. Again, it's a prism because it has two bases. So this is a base, and this is a base, and they're triangles, so triangular prism. It is 1,008 cubic centimeters, the volume. Find the base height. So volume equals the area of the base times the height of the whole object. So some of these things are going to be obvious to plug in. We know the volume. It's 1,008. The area of the base is a little more complicated in this one. So area of the base will be 1/2 base times the height because the base is a triangle. Here's the issue, as a lot of you can probably see. We know the area of the base is 1/2 times the base. A lot of people can see the base. It is 12. However, you don't have the height of the triangle. Height of the triangle, so you're only looking at the triangle. Don't worry about the three-dimensional portion. We're only looking at this piece. What is the area of this piece? In order to find it, you would need to know the height from the very bottom of the object to the very top of the object, and you would see this right angle. However, we don't know that. So what we're going to do is we're going to put h for height, and we're actually going to plug this into the formula. So we can simplify it. 1/2 of 12 is 6. So we're going to plug in 6h. I know that looks really complicated, but I promise in a second you're going to see that the only thing that is missing is the height of our base. Alright, and then the last thing to plug in is the height of the whole object. So of the entire object. So it's what pushes the two bases apart. Height does not always mean up and down when you're talking about a three-dimensional figure. So your height is going to be what pushes your two triangles apart. So that would be 21. So if you notice on this right side, we have 6h times 21. you can multiply the numbers together. 6 times 21, which is 126, and then h. So just like if we said 6x times 2, that would make, that's a lot of x's, sorry. 6x times 2, which would make 12x. All we did was multiply the numbers and then you drop down the h. That's just algebra. So now on the right side, all we have left is 126 times h. The opposite of 126 times h is divided by h. Nope. What am I saying? Divided by 126. Sorry. So h is being multiplied by 126. To get rid of multiplying by 126, we have to divide by 126. Which is 8. So the height of this triangle in the front is 8. And that would be the final answer. So now we can move into 11.6. It's about pyramids. Normally I show you a very cool video relating the volume of prisms to the volume of pyramids, but I am not that technologically savvy, so I can't put the video in this video. I'm sure there's a way, but I don't know how. But basically there is a relationship between prisms and pyramids, and here it is. The volume of a pyramid is 1/3 times the area of the base times the height of the object. So literally in this video it takes a cube and then it takes a a square pyramid, and it fills up the square pyramid and dumps it into the cube so that you can physically see that a rectangular prism is 3 times a pyramid, and a pyramid is 1/3 of a prism. So it's literally going to be the same exact formula. The only difference is that it's going to be the 1/3. So we're going to do the same thing that we were doing with prisms, except for we will do 1/3 after. And I'll show you how to do that. So I'm going to write in the formula. Volume equals 1/3 times the area of the base times the height of the object. So if you remember, there's only one base in a pyramid, and it'll be across from the top vertex. So we got a triangular pyramid here. So to find the area of the base, we are going to use the area formula for a triangle, because our base is a triangle. So 1/2 base times height. Remember that this little h represents the height of the triangle only. So the only thing that you should be visibly seeing is what I have in green. We're only looking at the triangle. So the base of the triangle, we got 6. And then the height of the triangle is from the very bottom of the triangle to the very top of the triangle, which is signified here. So 4. Again, it does not matter what order you multiply in. 6 times 4 is 24. Half of 24 is 12. So the area of the base, area of the base is 12. I'm going to keep my 1/3. And then times the height of the entire object. The height is from the very bottom of the object to the very top of the object. So, from the very bottom to the very top, you'll usually see this right angle. I'll erase the other one so you can kind of focus. You'll see the right angle because, again, it's signifying that that is the absolute height. That is straight up. So the height here is 9 centimeters. You can do this a couple ways. If you're not good with fractions, you can do 1/3, multiply 12 and 9 together, which is 108. If you don't have a fraction button, you would take 108 and divide it by 3, and that's how you find the third of it. So that would be 36. And then it would be centimeters cubed, because we're still talking about volume. So this is the same exact process as a prism, except for you're going to do 1/3. Number 2, we're going to use the same formula. Except for, there we go. So 1/3 area of the base times the height of the object. So the base, again, is going to be across from this top point. So it's a square actually, but you can still use length times width, which would be 6 times 6, which is 36. I'm going to drop down my 1/3. 1/3 times the area of the base, which was 36. And then the height of the whole object, again, is from the very bottom to the very top, and it is 8. So again, we're going to multiply. 36 times 8 is 288. And then again, you can do 288 divided by 3 if you don't have a fraction button. You can do 1/3 times 288, or you can do 288 divided by 3. They're literally the same thing. Either way, you're going to get 96. Is it still centimeters? Nope. Inches cubed. Sorry if we're moving kind of fast. It's really hard to gauge how fast or how slow to go when it's just me and I don't have someone in front of me. So you can always pause and go at your own pace. This next one, we're just continuing through area of the base. This one's actually easier. It looks harder, but the area of the base was given to us, and it's 27. And then the height of the entire object. If you see, they gave this bracket. That's the height. So we're going to multiply 27 times 5, which is 135. Again, you can divide that by 3. It's the same thing. It's multiplying by 1/3. And you get 45 centimeters cubed. So this one we didn't really have to do too much work. We didn't need to do any formula for the area of the base because they had given it to us. And then the last on this page, go ahead and highlight that base. It is a rectangle, so length times width, 4 times 1, which is 4. So we're going to have 1/3 times 4, and then times the height of the object. So if you notice, it's kind of a slanted pyramid. This 6, it doesn't notify you, but that's going to be your height. So again, 1/3, 4 times 6 is 24. You can do 24 divided by 3, which is 8. And it'd be feet cubed. This next problem, a pyramid with a rectangular base. So I'm just gonna, it's not gonna be pretty. Let's set our expectations. We got a rectangular base, and it is a pyramid. Oof. Beautiful. There we go. It has a volume of 6 cubic feet. So we're talking about volume, obviously. We already know the volume is 6 cubic feet. The length of the rectangular base is 3 feet, and the width is 1.5 feet. Find the height of the pyramid. So we don't know the height. So we knew the volume. We know the 1/3 is going to be there. We can find the area of the base. The base, they said, was a rectangle. So length times width. They told us the length is 3 and the width was 1.5. So 3 times 1.5, which is 4.5. And then times the height of the entire object, which we don't know, so we're going to call it h. We can multiply 1/3 times 4.5. Again, it's the same thing as dividing by 3. You'll get 1.5 when you combine those. Keep the h. The 1.5 is multiplying by h. The opposite of multiplying by h is dividing by, the opposite of multiplying by 1.5 is dividing by 1.5. One day I will say it correctly. So 6 divided by 1.5, which is 4. 4 and then feet, 4 feet. It is not cubed because we just found the height of the pyramid. We did not find volume. We found a linear or lateral length, so it's not going to have squared or cubed. We've got two more. The pyramids are similar. So again, this means it's the same shape, different sizes. Find the volume of pyramid B. So this is the formula we used with prisms. It's going to be the same one. Side 1 over side 2 cubed equals the volume of the first over the volume of the second. So the side they gave us is the height, actually. So we're going to do 15 over 10 cubed. So remember that it matters that the top come from the same figure and the bottom come from the same figure. The volume of the first figure, where we got 15, is 125. We don't know the volume of the second, so I'm going to put V. Remember that you can reduce fractions. I highly recommend it. So 15 and 10 are both divisible by 5. 15 divided by 5 is 3. 10 divided by 5 is 2. When you're cubing, you're multiplying something by itself 3 times. 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. So that's what our fraction is, 27 over 8, and it will equal 125 over the volume. Cross multiply 27V equals 8 times 125, which is 1,000. Divide by 27. So our volume equals 37.04 inches cubed. So something else to kind of check yourself to make sure that it makes sense. This first figure was bigger, so guess what the volume needs to be? Bigger, larger. So just check yourself. 37 is smaller than 125, so it would make sense. We have one more problem together, and it is another composite solid. Find the volume of the composite solid. So what we're looking at, it looks like we have a pyramid on the top of a cube. So we're going to find the volume of each, and we're going to end up adding these together because the pyramid is added onto the cube. So I'm going to find the volume of the top first, because why not? There's really no reason. You can find the volume of this bottom first, it doesn't matter. So first thing I want to notice is that this is definitely a pyramid. So the volume of a pyramid is 1/3 times the area of the base times the height of the entire pyramid. So let's identify what shape the base is. It is a square. Remember that on a cube, the top and the bottom are congruent. So this length is 6 because the bottom is. This length is 6 because the bottom is as well. So when we're finding the area of the base, we're going to use length times width. So area equals length times width, 6 times 6, which is 36. So the area of the bottom is 36. And then the height, it's the height of the pyramid itself. Because remember, we're finding the volume of the pyramid. So the height is 6. I'm going to multiply 36 times 6, which is 216. Oop. Multiply by 1/3, and that is 72. So the volume of the top is 72. Now we're going to find the volume of the bottom, and then we're going to add them together. So the bottom is a cube by definition, but a cube is a type of rectangular prism. It's a prism. So the volume of a prism is the area of the base times the height of the object. So the base, the shape of the base, is still a square, and it's still 6 by 6, and 6 times 6 is still 36. So the area of the base is 36. And then the height of the cube only. It's what separates the top and the bottom of the cube, which is 6. Multiply them together, you get 216. So if 72 is the volume of the top and 216 is the volume of the bottom, we're going to add them together and get 288, and it would be meters cubed. And that is the end of 11.6. Next week I will have a video. It'll be optional, but you can watch it to kind of review both 11.5 and 11.6 if you want more practice. Or you can always come to a help class, and I would love to do some problems together.